If y also goes to infinity, sorry, there's nothing. It's just infinity babies, I don't know. Two equations on the spot. The first one is y is equal to 1 over x minus pi, and the second one is r is equal to 1 over theta minus pi. Well, this guy is the rectangular guy, or you can also call this the Cartesian guy, but this guy is the polar guy. And let's focus on the graphs of these two people first. Do you think that the graphs of them are the same or different? Of course, they're different, right? And let's recall that in order for us to get a graph, one of the information that we want to have is, let's talk about the vertical and horizontal asymptote, right? So that's what I want to do with you guys in this video. Go ahead and try to find the horizontal asymptote and also the vertical asymptote of this guy and also this guy. And please pause the video and try this first. Okay, let's take care of the rectangular guy first because it's not that bad at all. So let's do the horizontal asymptote. And what we do right here is that we pretty much just take the limit as x goes to infinity. And let me just do the past infinity first. And we take this right here, 1 over x minus pi. And of course, you can just plug infinity into here. You get 1 over infinity minus pi, which is still just 1 over infinity, which is just 0. And you also have to do the negative version, just in case sometimes you end up with two horizontal asymptotes, just like the inverse tangent graph. But in this case, if you plug in negative infinity down here, you get 1 over negative infinity minus pi is still 1 over negative infinity. If you want to say that's negative 0, okay, fine, whatever. But I will say this is still equal to 0. Therefore, the horizontal asymptote in this situation is just y equals to this number. So remember, for the horizontal asymptote, we want x to approach positive infinity or negative infinity and look for the y values, right? And in this case, we don't have one y value, so that will be the only horizontal asymptote. And secondly, let's talk about the vertical asymptote of this guy. Pay attention to the denominator. And you know that x cannot be equal to pi in this situation, so we know x is equal to pi. That's the vertical asymptote. So you get the like vertical dashed line, right? Well, let's talk about the technical part. X is equal to pi, it's a vertical asymptote because of the following. Because if I take the limit as x approaching pi, and I will have to break down into two situations. The first one is pi minus, you can do the minus first or the plus first, up to you. Let's do the plus first. And then, of course, talk about the function 1 over x minus pi. In this case, if you plug in pi plus into here, you get 1 over pi plus minus pi. Pi plus minus pi is 0 plus. 1 over 0 plus is positive infinity. As you can see, when x is approaching this number, the y value goes straight up. That's why we have a vertical asymptote. And you also should do the limit as x approaching pi negative. And in this case, you actually end up with negative infinity. So similar reason, this time you go straight down, so that's still a vertical asymptote at pi. Now let's talk about the polar situation. This one right here. Well, it's not so easy anymore because remember, theta right here is the angle, and r right here represents the distance from the origin to the point. And in order for us to talk about the ha or the fa, we must be talking about the x or the y values, right? So, you know what? Actually, we don't have to worry because for all the polar guys, they are secretly parametric guys as well. And let me show you. All we have to do right here is to reveal the parametric equation version of that. That's pretty much it. And I will tell you guys, we have x, and let me put down x of theta, because theta is the parameter in our situation. All we have to do is to take r, which is given by this function. So I will just put down r of theta, and we multiply by cosine theta. And that's pretty much it. And you might notice, this right here, it's pretty much how we convert a polar coordinate to the rectangular equation, polar coordinate to a rectangular polar coordinate to rectangular coordinate, right? And in fact, I have a video for that. If you guys want to check that out, you can see the link in the description. Polar coordinate to the rectangular equation. Polar coordinate to the rectangular polar polar coordinate to the rectangular coordinate. And in fact, I have a video on how to do that. If you want to check that out, you can see the link in the description. But anyway, this is all we have to do to get the x coordinate of that point once you have the polar guide right here. Similarly, we also have y. I'll put down y of theta, which you do the same thing. You do r of theta, but in this case, you multiply by sine of theta. And now we'll be working with these two guys. And I will tell you, I will just simplify this a little bit. X of theta is equal to r of theta is given by this. And we multiply this by cosine theta. So let me put the cosine theta on the top. So we have cosine theta over theta minus pi. And then for the y of theta, this is just sine on the top. So we have sine theta over theta minus pi. And that's pretty much it. And now let's recall how we can get the horizontal or the vertical asymptotes. In fact, you have to really pay attention to sometimes x goes to infinity, what happens to the limit. If y turns out to be finite for the limit right here, then we have a horizontal asymptote. And if this right here, which is the y value, goes up to infinity, then this x value is the vertical asymptote. So we have to suspect, we have to pay close attention to the x and y to see which of them will go to infinity, and then just investigate the other to see what happens. For example, if x goes to infinity and y goes to a finite number, then we can say we have a horizontal asymptote. Similarly, if y goes to infinity, or negative infinity as well, and x goes to finite, in that case, what can we say? That's a vertical asymptote. So we are going to do this super carefully. And how can we end up with infinity for the x or for the y? Well, we see that on the denominator, we have theta minus pi. Of course, we have to pay attention to pi. So let me just write this down. We are going to be careful when theta is equal to pi. And in order for us to investigate this, we are actually going to take limits because we cannot really plug in exactly pi into all this expression. So let's go ahead. I will just say we are going to check. I will first take the limit as theta goes to pi plus first. And let me investigate x right here first. So I will put down cosine theta over theta minus pi. And I will be drawing arrows to represent that we are taking limits rather than putting down the LIM. Okay, so that way it's easier. Okay, so first I will just plug in pi plus into all the theta to see what happens. So this is going to be approaching to cosine pi plus, and this is pi plus minus pi. And now, what's cosine of pi plus? Well, let's take a look at the unit circle real quick. Pi is right here, and cosine is the x value of the unit circle. So as you can see, we have -1. Pi plus is a little bit down here though. So this is -1 and slightly, well, above -1. a little bit before -1, right? Because if you rotate a little bit bigger than pi, so you're actually down here, so you're actually slightly forward. So this right here actually approach -1 plus, so you can imagine -0.9999, okay? Over pi plus minus pi, this is like a number that's slightly bigger than pi, and then minus exactly pi. You get pretty much 0, but a little bit bigger than 0, so I'll put down 0 plus. Anyway, this is a negative number divided by a positive 0 plus, and this will tell you that it goes to negative infinity. Okay, so check this out. X, which is given by this equation, and it goes to negative infinity. So we are talking about this kind of situation, huh? So we may end up with a horizontal asymptote. I don't know, unless I check out what happens to y. If y also goes to infinity, sorry, there's nothing. It's just infinity babies, I don't know. Anyway, in the meantime, I will also take a look of y, which is sine theta over theta minus pi. And let's do this in your head real quick. pi plus into here, sine pi is 0, and then when you have sine pi plus, it's still 0 plus. And on the bottom, you also get 0 plus. Anyway, that's a 0 over 0 situation. So what we will do is we are going to use L'Hopital's rule because we have a 0 over 0 situation. We use L'Hopital's rule. And to show work, I will tell you, let's go ahead and differentiate the top and also differentiate the bottom with respect to theta. On the top, sine theta has the derivative cosine theta. On the bottom, the derivative of theta minus pi is nicely equal to 1. And I don't want to take the derivative anymore, but rather I will plug in pi plus into here, so I get cosine of pi plus. And as you can see, this is pretty much negative 1 plus. So in another word, y is pretty much negative 1. Therefore, you see that x is going toward negative infinity and y is toward negative 1. So what is the conclusion? For this one right here, we do have a horizontal asymptote, and let me just write it down somewhere. Let me just put on horizontal asymptote. Y is equal to negative 1, right? And technically, you should also be checking pi minus. But I will leave that to you, okay? I'll just say you check theta goes to pi minus, okay, yourself. And on the exam, do not write this down, okay? You must do the work to show the instructors. Do not just tell the instructors that, hey, check this yourself. That's not cool. And in fact, this is the only thing I have to check because this is the only number that will cause the infinity for x or for the y. And then we see that it actually is a situation that x is some kind of infinity. This was the negative infinity situation. And in the meantime, y turns out to be finite for the limit. So we do have a horizontal asymptote. And I will tell you, there is no vertical asymptote. And that's it. Hopefully you guys all like this video. Maybe I'll do more of this polar guys with you guys. Leave a comment down below and let me know if you guys want to see more. Anyway, that's it.